All right, so we're going to take some notes on equations as functions. This is pretty much a relatively easy topic. It really relies, though, on substitution. So the substitution property, right, is if A equals B, right, then wherever I see an A, I can switch for B, right? So essentially, again, right, we're going to be utilizing this idea of the substitution property quite frequently throughout the year. This is just going to be another example of that, how you do it. Instead of just doing substitution once for a problem, we are now going to be doing repeated use of an equation and just recycling a problem and just keep reusing, resubstituting different numbers in, getting different outputs, and then to claim that we create something so that we can plot them on a graph. That's all we're doing here. So the notes here basically is functions can also be represented by an equation. Okay, so functions, like we talked about yesterday, what we're special about them, you can also represent them with equations, right? Not just a graph or ordered pairs or points. And these equations, okay, will often generate for you ordered pairs. So the equation literally breaks it back down into what we had yesterday, so that we can plot them. So now the difference is what we're going to call everything now, because we're talking about substitution. So we'll take this thing that's called an input, and the input will result in a certain output. So with that being said, right, inputs are commonly the X variable and the output is commonly the Y variable. Does it mean that all X's are considered inputs? No, it doesn't necessarily mean that. It's just for us for today, what we're going to be working on is a lot of Y equals equations where it has it written as a form of plug in for X. So then from here, the graph of an equation is the set of all its ordered pairs, okay, which literally forms a line, okay, or a curve. Okay, so all graphs are either lines or they're curves. So what we do is we take all of those ordered pairs, we plot them, and then basically we see what it creates. So the next thing I want you to kind of think about as it deals with a function is we're just going to call them some specific names, just some review. I hope you've already heard this before, but just a quick reminder, the X value is called the independent variable. Okay, so you may hear me say who is the independent variable, and again, it's because you pick it, and the Y value then is called the dependent variable. Okay, and again, it's no trick here. We call it the dependent because it depends on the value of X. Okay. So from here, basically what I want to do is I want to just go through two examples to show you what it is that you're going to do here. And then from there, you can essentially, do the couple others. So I'm going to do about 2 problems here, or 3 problems, 4 problems maybe overall. Probably 3 examples here of what it means to be given an equation, and then it says graph the function by table. So to get into it, right, what I have here is I've got this table of X values, and if you notice, this table of X values corresponds directly with this equation that also has an X in it. This table also has a Y value, which then also corresponds with this equation because it's got a Y in it. So essentially what I'm asking you to do here is I'm asking you to replace the value of X with -5, calculate it to figure out the value of Y, and then write that answer in the table with -5. And then I'm going to ask you again to plug in the number -4, calculate the value of -4 in the equation, and then place that answer next to the -4 in the table. So that's all we are doing here. So number 1, I would hope we could do some mental math with this one. So if I replace the value of X, okay, with if I replace the value of X here with -5, Okay, so we would get y equals, and I'm just going to use parentheses here for a second, -5 plus 4. Now the parentheses don't matter because there's a 1 in front of the variable, but I'm just going to use them. So y equals -5 plus 4, and -5 plus 4 is -1. So the answer is -5, -1. And there you go. And then I do the same thing. It's just I replace that -5, and instead of saying -5, I now place a -4 in there. And -4 plus 4 is 0. And I just keep playing this game. I keep swapping out, okay, that value, and I keep plugging the next number in. So -2 plus 4 is 2. And then I swap that out, and I say, hey, well, let's plug 0 in. Well, what is 0 plus 4? And 0 plus 4 is 4. So from here, what I have is now I've got a set of coordinate pairs, and all I'm going to do, okay, is I'm going to graph these specific points. Now, there could have been more, right? I could have picked more values. So what I'm hoping to form here is some sort of a pattern. And from that pattern, I'm hoping just to extend that pattern out so I can go ahead and just put arrowheads on the end. So we go to the point -5, 1, 1, 2, 3, 4, 5, down 1. We go to the point -4, 0. We go to the point -2, positive 2. And we go to the point 0 and then 4. So up 1, 2, 3, 4. And what I've got there is it looks like I've got a nice straight line for a pattern. So I'm going to go ahead and I'm just going to extend it, keeping it on that pattern, and put arrowheads at the end. And then I'm done. And that's all it is that you're expected to do here today. It's expected to just plug numbers in, calculate their value, and plot their answers. So number 4, let's take a look at that, right? So if you wanted to pause the video right now and try to do 2, 3, and 4 on your own, because you pretty much got the idea of what's going on, awesome. Now's a good time to pause it. But if you don't want to pause it, then obviously I'm just going to go through this one. So number 4, it's the same exact thing, except number 4, just be very cognizant that parentheses do matter. So now, just because of lack of space on my screen here, I'm going to do my work over here to the left. So in number 4, the first one says y equals, and it says -3 over 2, and then it says x, but now I'm going to replace x with the numbers that it says. So the first one's a -2. So remember your parentheses, they are important, and then plus 2. Now, again, if, computation of fractions is not your thing, you got a calculator, you just got to type in this entire expression as you see it with the parentheses. You don't even need to hit the multiplication button. Calculator is actually designed that it knows that a number next to a parenthesis is multiplication. So if you plug that whole entire expression in, you should get the value of +3, and +3 plus 2 is equal to 5. So you get an output of 5. Okay, the next thing is we're going to plug in a 0. Well, I'm not going to actually plug that in. We should know 0 times anything is 0. So -3/2 times 0 is 0. Add 2 to that, and you get +2. All right, but if we plug the +2 in this time, right? So let's go back to our problem here before. Ooh, excuse me. And if we plug in +2 here, I get -3/2 times 2. Which is -3 plus 2, which makes the value of -1. So in the table next to 2, I place in -1. And then I'm going to place the value of 4, so y equals. So if I replace this with the value of 4, turning that into a 4, I no longer have -3. I've actually got -6. And -6 plus 2 is -4, so plugging that in. So now that these are plugged in, what I'm going to go ahead and simply do is graph them. So -2, 5. So 1, 2, 3, 4, 5. Plot my point. That's not the pencil. So plot my point at -2, 5. Plot my point at 0, 2. Plot my point at 2, -1. And I plot my point at 4, -4. So my points are plotted, and look at that. Again, they look like they're forming a straight line. I'm going to go ahead and connect them, trying to continue that pattern, and draw the arrowheads at the end, and I'm done. So that's all that this lesson really is today. There's one other demonstration of, instead of giving you something as a table, I'm going to give it to you in set list value. So let's take a look at another way to say, hey, here's a bunch of x's I want you to plug in to create some y's. So here So another way of doing this, right, is to give you a function and say, hey, here is its domain, determine its range. Now remember that domain represents a set of x values. So if the domain represents a set of x values, what I'm saying to you is that this equation in number 7, y equals x minus 5, only exists at 4, 6, and 8. So I only want the numbers for 4, 6, and 8. So essentially for this one, I need to create the values of y that exist for an x value of 4, an x value of 6, and an x value of 8. So in this particular case, here we go. So again, keeping in mind that domain means the set of x values, what I'm simply going to do is I'm going to take, this number 4 here, all right, and I'm going to take that value of 4, and what I'm going to do is I'm just going to do substitution. So this is when x equals 4. So y equals 4 minus 5, and 4 minus 5 is negative 1. And then I'm going to do the same exact thing with 6. So y equals 6 minus 5, and 6 minus 5 equals 1. And then again, I will do that with the value of 8. So the value of 8 is 8 minus 5 is equal to 3. And now what's important here is that the problem said find the range values. So now what I'm going to do for my answer is I'm going to write the word range. I'm going to put these two little colons, right, to where I can write equals, okay? And you're just going to write your list. So now I go back to my numbers, and I'm simply just going to write them in order from least to greatest. So I plugged in 3 numbers, and then I got 3 numbers out. I got negative 1, 1, and 3. So writing them in order from least to greatest, I get negative 1, then 3. So basically, that becomes the end of my problem. There it is. It's done. And the rest of them are just done the same exact way. The most important thing about this particular answer is that when you calculate your values, you don't just write them in the order that you've got them. This one happened to be that way. But please, when you write the range, write them in order from least to greatest. And that's it. That is your lesson for today. That's enough for you to do these practice problems in class as a classwork assignment. So finish the rest of the problems that are in this area. And then also this should be enough for you to be able to do the homework that is assigned with this section if you wanted to get a head start on that as well.